47, use logarithmic differentiation to find the derivative of this expression right here. So what's going on? Let me rewrite this as x times, we're divided by square root of x plus 2. That's x plus 2 to the negative 1/2 power. And divided by x cubed plus 1, so that's x multiplied by x cubed plus 1 to the negative first power. Okay, so what we're going to do is, let's take the natural log of both sides here. Natural log of y is equal to natural log of this. Natural log of this. Why are we doing this? So natural log of y is going to equal, so the natural log of this times this times this is equal to the natural log of this plus the natural log of x plus 2 to the negative 1/2 power plus the natural log of x cubed plus 1 to the negative first power. And for these exponents, we also know by logarithm properties we can pull those down out in front. So natural log of y is equal to natural log of x minus 1/2 times natural log of x plus 2 minus natural log of x cubed plus 1. Okay, so at this point now, we're ready to take the derivative. Taking a derivative with respect to x everywhere. Okay, so the derivative with respect to x of natural log of y is going to be y prime of x divided by y. Where does that come from? The derivative of natural log of y is 1 over y, but chain rule says that we need to multiply by dy dx, or y prime of x. Derivative with respect to x of natural log of x is 1 over x minus the derivative 1/2 times the derivative of natural log of x plus 2 is 1 over x plus 2 minus the derivative of log of x cubed plus 1. So there's an x cubed plus 1 downstairs. Upstairs is the derivative of this 3x squared. And so then to finish this off, we just need to multiply on both sides by y. So y prime of x, or dy dx, is equal to y. What was y originally? X over square root of x plus 2 times x cubed plus 1 times 1 over x minus 1/2 times 1 over x plus 2 minus 3x squared over x cubed plus 1. And so this kind of final answer here, your derivative is equal to the original expression times something that looks like this. This is a pretty typical answer, final answer when you're performing logarithmic differentiation. Okay, that is problem number 47. Let's go to 48, asking for the derivative of f of t is pi to the 5t minus 2. Note here that this pi is a constant. So a constant raised to some power of t here, so where the power is, I should say, some function of t. How we're going to do this, I'm just going to, there's probably shortcuts we can do here. I'm just going to do this from scratch. Actually, again, using logarithmic differentiation. So y is equal to pi to the, I'm identifying here f with y. Y is equal to pi to the 5t minus 2 power. Natural log of y is equal to the natural log of this. And then we can bring down the exponent. So natural log of y is equal to 5t minus 2 times natural log of pi. Okay, so now we take the derivative of everything with respect to t here. On the left, the derivative of natural log of y with respect to t will be dy dt over y. Once again, that's the derivative of natural log of y is 1 over y multiplied by dy dt. On the right here, we have 5t minus 2. Derivative of 5t minus 2 is 5. Natural log of pi, this is just a constant. So we're seeing this as a constant times 5t minus 2. The derivative of the constant times 5t minus 2 is just the constant natural log of pi times 5. And then again, we bring the y to the other side. dy dt is equal to y. Y is pi times 5t minus 2 times 5 natural log of pi. So this natural log of this 5 comes from, there's a 5, the coefficient of 5, coefficient of t in the exponent is 5. Natural log of pi comes from when you're raising, when you have a constant raised to something power, you pull out, you end up with a factor of natural log of the constant.